So some of you, you're looking at this, you're trying to figure it out. I want to at least come to a conclusion on maybe part of this. It says write a formula for a cone, for a cone's total surface area. So it's basically this, think of the cone, it only has two surfaces. It's got the bottom, and it's got this curved sort of triangle on here. So it's this plus the bottom. And that's sort of obvious, sort of simple. What's the area of the bottom? Well, the area of the bottom is just pi r squared. So, as you think of a cone, area of the bottom is just the area of a circle. This garbage we came up with here is the lateral area. So if you just add in the bottom plus the lateral area, you got your formula. Pi r squared plus pi r l. So you might be feeling a little heavy on the formulas. You got to know, this is the other big one for the cone, you got to know it. It should be obvious how it's different from the other one before it. It only has one base, so there isn't a 2 in front of it. A cylinder had a 2 in front of it. And pi rl is a little different because it's got a slanted height in there. The second thing is not a new formula. It's kind of nice. How does the cone's volume relate to, of course that's silly, how does a cone's volume relate to a cone's? Dummy, Mr. Hess. That should say cylinder on there, obviously. On your paper it says cylinder. I got to fix it on here. So it's the exact same relationship I showed you with the pyramid the other day with water. This is a third of that volume. So it's the same exact formula. You do base area times the height and divide by 3. The only thing we might want to change in here, instead of using base area, we might want to just plug in pi r squared, since the base is a circle again. So you can write it either way, 1/3 pi r squared h. You can also put pi r squared h over 3. I often see people like to write it that way, pi r squared h divided by 3. Just want to make sure when you're doing a cone, you don't forget to divide by 3, just like you did with the volume of a pyramid. And again, volume is capacity. It's cubic units inside. Surface area is the actual physical thing that makes up the cone, the space, on the surface. So maybe try these two. These are two simple examples. It does say to solve for these in terms of pi. I want you to get sort of comfortable seeing that. There's one of the formulas you might want to be using. There's the other one, attack. So I'm going to give you one piece of information that this edge here, it's not even an edge, it's a cone, so it's just sort of a dimension, a distance on there, is 7, and that's 5. Good time to pause and try this one on your own. You will notice that if I ask you to find both of these, there's always an application of Pythagorean theorem. And there's one of these will be easier. If I give you this one, I haven't given you the actual height. It makes this a little harder because you don't have the actual height. I gave you, this is the slant height, so it makes this problem a lot easier. Plug in 5 for your radius, you get 25 pi. Plug in 5 here, plug in the 7 there, and you get 35 pi. That's a pretty simple problem for finding surface area. So the lateral area, and I'm asking for all three of these, surface area, lateral area, and volume. The lateral area is just this part of the equation, 35 pi. The total surface area is just adding in the 25 pi, adding in the circular base. I'm not showing a lot of calculations on there. It's sort of something that's pretty simple because it's just sort of plug and chug for what's given on there for that one. It's a little tougher to find this one because you got to find the height. And again, if you don't know the height, it's just like we did in the past. You got to use Pythagorean theorem. So h squared plus 5 squared equals 7 squared. I believe you get, and I did this one in radical form, 2 rad 6 for the height. You can double check me. That looks like that's probably square root of 24. So it's probably 4.9 or something like that. And that's why I say I'm leaving this in terms of pi. Usually when you leave in terms of pi, you work with radicals. It's the exact format for things as opposed to approximations. So if I simplify this whole thing, I'd get 25 times 2 is 50. Rad 6 times pi and divided by 3. So you'll see this ugly looking answer and you go, what is that? That's often the way answers are left in terms of pi. You'll see multiple choice answers, I think, on the final exam like that. I don't like it, but I'm a math teacher, so I got to make sure you guys have seen it, you're comfortable with it, you've learned it. I would love to do 50 times rad 6 times pi and then divide by 3 and get a beautiful decimal. So I don't have any idea how big that is. But that's a math answer right there that you want to be comfortable with, both formats, the math guy format and the practical one. Second one, over on the right here, 10 meters. and 12 meters. So big cone. Meters are big. So big cone. They're going to use this on top of a silo to collect corn or something. I don't know what the heck they're going to do with it. So again, one of these is usually easier than the other. Because I gave you the actual height, this is going to be easier. I didn't give you the slant height in this case. And boy, I keep throwing this Pythagorean triple at you. If this is 10, that means the radius is 5. If the radius is 5 and that's 12, of course the slant height is going to end up being 13. So you'll very quickly remember and figure that out. It's been on the last 3 sections of notes, I think. So my slant height is 13. And then all it is plug and chug. 13 times 5. 5 squared again. And I think you end up with 90 pi square meters. And the volume was the easier one in this case. So all you got to do is do, the height, 12, times the radius squared, which is 5 squared, which is 25. Don't forget to divide by 3 at the end. And again, I'm breaking this apart. The lateral area, that's from up here. The lateral area was 65 pi. And the volume ends up being 100 pi. And if you get 300 pi, it's because you forgot to divide by 3. And if you get 314, it's because you didn't leave pi out of your answer. So again, I like to multiply by pi, but you're going to see sort of both formats. That's it for 10.4. We'll do 10.4b, which is really just sort of an integration of cones and cylinders. You don't have to know this to do the homework. Like I mentioned earlier, this is to get you ready for the weekend homework if you wanted to work ahead and not have any weekend homework, nothing to do on Saturday, Sunday. You can certainly look on Schoology for the next assignment. Or I can give it to you up here, which I have it somewhere here. Somewhere here. Is that it? No. No. Here it is. So if you want to work ahead, this is the problem with cones. These are the problems for cones. This is the one that's due Monday. So you got one due on Friday with cylinders, and this is the one that's due on Monday if you want to work ahead. Enjoy, people. Have a good day. See you on Friday.